Okay, let's get the webinar started. Good morning, good evening, good afternoon to all who joined the webinar today. I'm Karthik Anandrao, Senior Product Consultant and Evangelist for ManageEngine. With engineering and MBA degrees from reputed Indian institutions, I have over 17 years of IT experience, serving in different capacities, including system and network administration, IT management, and consulting. I have traveled across the globe for implementation, consultation, and training of ManageEngine products and solutions. It's nice to have so many of you join the webinar today. It goes to show that the good old SNMP still rules the roost. This webinar, to begin with, will be a two-part series. Part 1 will cover the SNMP basics that we need to know as a network or server administrator. The second part of this webinar series, to be held in the second or third week of next month, will address troubleshooting MIB errors, working with MIB browsers and so on, along with answers to questions that need detailed explanations that are raised today. So let's take a look at today's agenda. To begin with, we will see what SNMP is all about and drill down to its components and their functionality and how these components are interrelated. We will then take a look at the ports which SNMP uses and the ports that you may have to open through the firewall to get SNMP working across the WAN. Following which, we will get to know about the different versions of SNMP, a little bit of few SNMP jargons that will be frequently used in this webinar and through the rest of your lives if you are one in way or other related to SNMP. MIB, it is the acronym for Management Information Base, and it forms an integral part of SNMP implementation. OID stands for Object Identifier, and these are defined within the MIB database. After a session on MIBs and OIDs, we will look into the basic SNMP commands. We will see how SNMP communication happens and how the commands help with the communication. Traps will be the penultimate item in our agenda, and then we will take a look at SNMP tool from ManageEngine. SNMP stands for Simple Network Management Protocol. This is the standard protocol by which you can manage devices like router, switch, firewall, server, temperature controller, UPS printer on IP networks. To be precise, it is a standard way to monitor hardware and software from any manufacturer, from Cisco to Juniper, from Microsoft to Unix, to any vendor equipment. It is a part of Transmission Control Protocol, Internet Protocol, which is called as the TCP/IP suite, and it uses UDP as a transport protocol. UDP here stands for User Datagram Protocol. The main components of SNMP are SNMP Manager, SNMP Agent, Managed Devices, and Applications. The image that floats to your right is a typical SNMP architectural diagram within an IP network. The user receives alerts through the management station, otherwise called a monitoring solution, which in turn pulls performance statistics from servers and network devices. SNMP Manager sends a request to the SNMP agent, which in turn passes on the request to the managed device. Managed device then responds to the request on hand and sends the necessary output to the SNMP Manager. Let us take a look at the standard definition of these components, and examples will help understand these components better. We'll start off with managed device. Managed device could be a network device on an IP network such as a router, switch, firewall, load balancer, temperature sensor, printer, UPS. It could be any server, be it physical or virtual, any operating system like Linux, Solaris, Windows, HP UX, Debian. In short, it is a managed device could be any device with an IP address and an SNMP agent. So what is SNMP agent? Every hardware device manufacturer configures SNMP agent on the managed device. The primary responsibility of the SNMP agent is to collect management information about its local environment. SNMP agent stores and retrieves information as defined in the MIB database. MIB, as we all know, stands for Management Information Base, and the manufacturer owns the MIB for a device. SNMP agent also signals an event to the manager. Examples of SNMP agent are Cisco devices bundled with Cisco SNMP agent, while Unix Linux operating system comes bundled with NetSNMP packages. On a Windows operating system, the SNMP agent is disabled by default. You can enable it from the programs and features, turn Windows features on or off panel. The next component, the third component, is the SNMP manager. The role of an SNMP manager is to collect management information from SNMP agents of managed devices and store them in a more readable fashion. It could be any network monitoring protocol like Op Manager or SolarWinds, or could be any network monitoring solution like NMS or EMS. NMS here stands for Network Management System, and EMS stands for Element Management System. So the next slide is on ports used by SNMP. SNMP uses port 161 over UDP, and SNMP trap, which is nothing but a notification from the SNMP agent to the manager, uses 162 over UDP. We will talk about traps towards the end of the session. In case you have a firewall that separates your SNMP manager and managed device, you will have to open these ports bidirectionally. The next couple of slides, we will be talking about SNMP versions. So the different versions of SNMP are SNMP v1, SNMP v2c, and SNMP v3. SNMP v1 is widely used and the de facto network management protocol. It is available since 1988, and the authentication happens with the help of community string. SNMP v2c is a revision of SNMP v1. The SNMP command get bulk request was introduced in SNMP v2c. This version of SNMP has quite a few improvements in terms of performance, security, and manager-to-manager communications over SNMP v1. While these are the versions widely used, they lack in terms of security, and community string is passed in clear text. This is something which is unapproved by security analysts wide across the world. So network analysts and security analysts needed a much more secure network management protocol, and hence they came up with the SNMP v3 standards. This version of SNMP adds security and remote configuration capabilities. Each SNMP entity has an identifier called the SNMP engine ID. Communication is possible only when the SNMP entity knows the identity of its peer. Traps and notifications are exceptions to this rule. SNMP v3 has support for security models and contains specifications for USM, which stands for User-Based Security Model. The standard communication mechanisms available in User-Based Security Model are communication without authentication and privacy, which is called no auth, no priv. Communication with authentication and without privacy, which is called auth, no priv. communication with authentication and privacy, which is called auth-priv. Authentication protocols that are supported in USM are MD5 and SHA, and the privacy protocols supported are CBC DES and CFB AES 128. You can Google these terms and learn more about them. Understanding these terminologies within this webinar is considered out of scope. We are still to continue on SNMP v3. It provides a secure environment for systems management by covering discovery procedure. It also has got a time synchronization procedure which helps to facilitate authenticated communication between SNMP entities. SNMP v3 provides SNMP framework MIP to facilitate remote configuration and administration of SNMP entity. It also provides user security model MIBs to facilitate remote configuration and administration of security model. VACM MIBs, otherwise called the View-Based Access Control Model MIBs, are also provided by SNMP v3 to facilitate remote configuration and administration of user access model. SNMP v3 also provides security goals that include protection against modification of information, masquerade, message stream modification, and disclosure. This version of SNMP addresses issues related to large-scale deployment of SNMP, accounting, and fault management. It primarily focuses on security and administration, security through strong authentication and data encryption, and administration through notification originators and proxy forwarders. This is going to be the last slide on SNMP v3. Since this is a more secure implementation of SNMP, we thought we will cover it in depth. SNMP v3 security depends on USM. USM stands for User-Based Security Model. This model provides authentication and encryption functions and operates at the message level. VACM, which stands for View-Based Access Control Model. This model determines whether a node is allowed access to a particular MIB object to perform specific functions. This model operates at the PDU level. TSM, which stands for Transport Security Mode. It provides a method for authenticating and encrypting messages over external security channels through SSH and TLS DTLS. SNMP v3 implementation is highly secure in terms of confidentiality, data integrity, and authentication. Confidentiality, it prevents snooping from unauthorized source. Data integrity is ensured by the way that a packet is not tampered with. And authentication, it verifies if message is received from a valid source. The next slide is on MIBs and OIDs. We start off with OID. OID stands for Object Identifier. It is something that can gather information about on a SNMP-enabled device. OIDs are identified by names called the object name. Each OID has a data type. It can be a counter value or a string or an integer or a gauge. The level of access on each OID is read-write. It can also provide a range of information. Quite a few examples have been listed on the slide here. Interface up-down status, RxTX traffic errors, discards, process information like the path, ID, CPU memory, and number of instances, CPU speed and utilization, total used or free memory, and total used or free disk space. Each of these is an OID, and each has got an object name, and each OID has a different data type. OIDs are defined in MIBs, and each OID is unique and is specific to a device or its type. OIDs can be scalar or tabular, just like sys uptime, which is scalar, and interface data, which is tabular. OIDs are typically a dotted list of integers, as you can see in the next slide. So let us see how to locate sys uptime from RFC 1213 MIB. You can use a standard MIB browser tool to load the RFC 1213 MIB. There's also one from Manage Engine, which is available for free. We'll also have a look at it in this session. If you try to open the RFC 1213 MIB with a notepad or a WordPad, it becomes quite difficult for a beginner to understand the structure. As you gain more knowledge on SNMP, it becomes easier to understand the MIB structure, and thereupon you can troubleshoot problems that you come across while loading a MIB. Let us look at the sys uptime, and the structure goes as follows. It starts with ISO, DOD, Internet, MGMT2, MIB2, system, sys uptime, which is the third one in the list. We'll also have a look at the MIB tree diagram, which will help you understand things better. And when you load the RFC 1213 MIB through Manage Engine MIB browser tool, this is how you locate the sys uptime OID. I'll freeze the screen for a minute here so that you can take time to identify where the sys uptime OID is. Let's take a look at MIBs. MIB, as you all know by now, it stands for Management Information Base. It is a collection of OIDs. The SNMP agent on managed device maintains an information database describing the managed device parameters. Examples of such parameters are CPU, memory, disk, process, interface, statistics, and so on. The SNMP agent retrieves the value of the requested information from the MIB when the SNMP manager requests for it. MIB also defines the managed objects that a SNMP manager can request from the SNMP agent. In short, it is a set of questions that a SNMP manager can ask the agent. MIB comprises of managed objects identified by OID. There can be two types of MIBs. Standard MIBs like the RFCs, and custom or private MIBs like the ones provided by device manufacturers such as Cisco, HP, Huawei, Nortel, and so on. So here is the MIB tree diagram that I was talking about a while ago. As you can see the image on the right side of your screen, the MIB tree starts at the root level and branches out to ISO on 2 other levels. ISO then branches out to 4 other levels, of which organization is 1. Organization then branches out to DOD, then to Internet, and Internet then branches out to MGMT2. MIB2 then branches out to Interface, ICMP, TCP, UDP, SNMP, and so on. Let us now take a look at a few basic SNMP commands which are quite often used by monitoring tools. The first one in the list is get. It retrieves one value from the managed device. Examples can be sys uptime, sys description, sys name, sys location. The next command is get next. Retrieves the value of the next OID other than the one identified in the command. This is mostly used by monitoring tools, and one good example would be to retrieve values from the Ormon MIB. Get bulk is the third one in this list. It retrieves voluminous data, just like the one from if table. If table is nothing but your interface table. The set command helps to modify or assign a value to a parameter. Example would be to set temperature threshold on a server. Traps, these are notifications from SNMP agent to the SNMP manager when an event occurs in the managed device. Examples are link up, fan status, and so on. Inform, they are just like traps, but it includes a confirmation message from the SNMP manager. The last one in this list is response. This is a command which is used to carry back values or signal of actions directed by the SNMP manager. The next slide, or the one that is shown on your screen right now, helps you understand how a SNMP communication happens. SNMP manager is your NMS, which will receive traps and informs and will collect performance data from SNMP agent in the managed device. Managed device, as we all know by now, can be a router, switch, server, or a printer, or a desktop. Each of these managed device will have an SNMP agent, and the agent has management definitions and database in the form of MIPS. The next is on traps. We'll be talking about traps we have been talking about traps in a couple of slides earlier in this webinar. Let us see what traps are. Traps are asynchronous notifications from the SNMP agent to the manager about events happening within the managed device. It includes the current sys uptime, an OID that identifies the type of trap, and optional variable bindings. In order that specific events within the managed device are captured as traps, it is important to specify the destination address for the traps to be collected. MIPS contain the trap configuration variables. Traps usually listen on port 162 over UDP. Traps follow the SNMP version. It could be a SNMP v1 trap, or SNMP v2 trap, or inform, or SNMP v3 notification. An example of a trap has been given on the slide here, and this is how trap information looks like when received by a trap receiver. Let's talk about SNMP tool from Manage Engine. There are quite a few SNMP tools in the market, and you can Google them. These tools help to retrieve or set SNMP messages and traps. Manage Engine has one such tool by name Manage Engine SNMP MIP Browser. The highlights of this tool are it is available for free. There's a trap viewer which comes along with it so that you can receive traps all in one console. You can do get next, get bulk operations. You can set SNMP variable value. You can load MIBs. When you do so, if there are errors while loading the MIB, the error is displayed, and you need some expertise to rectify those errors. And most importantly, it is easy to use. And the part 2 of this webinar series will cover an hands-on with the Manage Engine SNMP MIB Browser tool. And what you see is a screen capture of the SNMP MIB Browser. Quite a few MIBs are preloaded, and SNMP commands are icon-driven, making it more user-friendly. You can copy those URLs from where you can download the SNMP MIB Browser tool, the FAQs on tool usage and feature highlights. In case if you're not able to copy them down, we will also be sharing this presentation and this webinar with you all. And we also have an SNMP community which is called SNMP Nuts and Bolts. It's an online community from Manage Engine where you can share MIBs. You can also upload MIBs to us or to the community to fix errors in those MIBs. You can share your thoughts on SNMP and its basics, or even on advanced topics of SNMP. We will also be sending an invite to all the participants today, and I would request each one of you to accept the group invite. And we also have a MIB database the short URL to the MIB database is given here. We have MIBs from quite a few vendors like HP, Cisco, Nortel, and so on. So we will spend some time here for questions. So there are a couple of questions from participants here. So gentleman has asked us, how can we know the OIDs of SNMP agent? The SNMP agents as such do not have OIDs. The agents have a MIB structure, and within this MIB structure is what you have the OIDs. I hope I answered your question here. Another gentleman has asked how Manage Engine will help and up to what level. We will help you with MIBs that you may need. Say for example, if there is a new vendor and you want the MIBs, we will try to find out in the best of our capacity. And in case if you have some errors loading the MIBs through the MIB browser tool, we will help rectify those errors. And there's another gentleman, I hope I answered your question, sir. And there's another gentleman who has asked us any free monitoring system that use SNMP that you can suggest for me. Free monitoring system that use SNMP. I'm not sure what this question would mean, but based on my understanding, I think that you want quite a few monitoring systems which use SNMP. Op Manager is one. I think 25 devices. You can monitor up to 25 devices for free. And in case if you have trouble enabling SNMP on devices, or say let us say Windows servers, we have a tool called as a Windows SNMP enabler that will help you configure SNMP on Windows devices. So I hope I answered your question, sir. And another gentleman has asked us, will all device support SNMP v3? It's based on the implementation of SNMP. So it's the manufacturer who has to decide what version of SNMP will the device support. There's another gentleman has asked a very interesting question. HP servers have ILO interface. Should we query SNMP against ILO or SNMP against the Windows SNMP agent? So usually HP servers have their own SNMP agent. So that's where we call it as the element management system. So they have their own SNMP agent. And when you install those agents, you'll have to query against the proprietary SNMP agents and not against the Windows SNMP agent. What is the difference in SNMP and WMI monitoring? That's again an interesting question. WMI is more real-time, and SNMP usually stores information, or it archives the performance data and then gives you the output. So that's the difference. So let's wait for a few more minutes to see some questions coming up. Is SNMP v3 available in Windows 7 as part of standard installation? Yes, I think so, but you may have to turn on the Windows feature from the control panel. From the programs and features, turn Windows on or off panel, Windows features on or off panel. Is this webinar recorded and will it be published on your site? Yes, it will be. Is it possible to monitor non-Windows device by WMI? WMI is a proprietary protocol of Windows, and hence you will not be able to monitor non-Windows devices. Is that all the questions that we have for today? Questions from the participants here. Can WMI detect temperature in faulty disks, or do we need SNMP for this? WMI can detect temperature. There's a WMI class which will help you identify what the temperature is. But for faulty disks, you can either use SNMP or the event log. So there's another gentleman who has asked, please explain the use of community string. So community string is the authentication for SNMP. That is the base with which a device, the SNMP agent can respond for a request from the SNMP manager. So that's the password. That's something like a password, which is used by the SNMP manager to pull information from an SNMP agent. Does it help to analyze Windows event logs? The answer is no. Are you planning to explain some fields of SNMP data unit like enterprise specific, etc.? I think we would take this up as in the part 2 of the webinar series. Thank you so much for your participation. I hope this webinar was useful, and I look forward to you all in the part 2 of this webinar series. Thanks again.